So in this video, we'll continue our stuff on the anatomy of the kidney. In the previous video, we talked about what kidney is, what excretory system contain, and we shortened it to the KUBU, that is kidney, ureter, urinary bladder, and the urethra, right? And I mentioned the structure of the kidney. I mentioned this one to be the capsule. I mentioned this one to be cortex, this one to be medulla or the renal pyramid, and this one to be renal papillae, this one to be calyx, that is minor calyx, this one to be major calyx, this one to be pelvis, and this one to be urethra. And we were able to check the arteries, which brings the blood inside the what? Inside the kidney, right? And we said the artery gives us a segmental artery, from the segmental artery to the interlobar artery, from the interlobar artery to the arcuate artery, to the radiated arteries, and to the arterioles, right? Now, remember I said we have two types of arteriole. We have the afferent arteriole and we have the efferent arteriole. And I told you that if you zoom it in well, if we zoom it in well, we are going to have something like this. We are going to have the we call it the cortical radiated artery, right? I call it cortical radiated artery. And I said they have arterioles, which I won't be able to like show here, but I'll be able to like show it later. So now this arterioles now goes into what we know as the peritubular capillaries. I'll be showing that later as well. Peritubular capillaries. Now, if you notice very well, this structure has arteries but no vein. So I have another structure here that has both arteries and vein. I see. So look at it. This is it. Let me show you it here. Now, look at this. This is arteries. Look at it. This is artery. This is segmental artery. This is interlobar artery, and it gives us everything. Now, we're now having the arteriole. Can you see? We're having the arteriole. Now, inside this place, we're having the arteriole. Now, the arteriole now deposits this blood inside the peritubular capillaries. You understand? Now, the peritubular capillary now comes down into the cortical radiated vein. Can you see this blue one is the vein? Cortical radiated vein. Remember that we have cortical radiated arteries. So we have cortical what? Cortical radiated vein. And this cortical radiated vein now moves down into the what? Into the arcuate vein. Look at it. This is the arcuate vein here. Can you see? This is the arcuate vein. So this is cortical radiated vein. Look at it. All this thread here. And this is the arcuate vein. Can you see? This is the arcuate vein. Now this arcuate vein now goes down into the what? Into the interlobar vein. That is the vein in between lobe. Interlobar vein. So as we have interlobar artery, we have interlobar veins. You understand? So it moves down into the what? Into the interlobar vein. Can you see it now? Now, all of them now goes into the what? Into the segmental vein. Can you see? We have segmental veins. Then everything into the what? Into the renal vein. So the renal vein takes the blood outside of the what? Outside of the kidney. That is filtered blood outside of the kidney. So it takes the filtered blood outside of the what? Outside of the kidney. So this is it. Can you see? Now, I hope you're getting it. Now, I said we have the arteriole, from the afferent arteriole to the efferent arteriole, from the efferent arteriole to the peritubular capillaries, from the peritubular capillary to the what? To the cortical radiated vein, from the cortical radiated vein to the arcuate vein, from the arcuate to the interlobar vein, from the interlobar vein to the segmental vein, and to the what? To the renal vein itself. You understand? So that is how it goes. Now, let me now show you the stuff that I say I'm going to show you now. So let us take the broad view of a what? Of a medulla. So we want to take only one of this. Let me just indicate that in the second slide, because that is what you used to explain initially. Now, we want to take only one of this. But it's only one of this. Just one. Just one of this. You understand? We want to see how it looks like the cross section of it. Remember, we are dealing with anatomy. Now, all these stripes that you see now, all these striated this thing, we are going to show what it is now. Now, look at it. This is how it looks. Can you see? It looks like a what? Like a pyramid itself. So this is how it looks. Now, let me now show you. Remember I said we have what? We have interlobar vein. So this red. Can you see this red? Let me zoom it in well. So this red, this is the interlobar vein. Can you see? It is in between the lobe. So this is one lobe. This is just one lobe. So this is interlobar vein. Can you see? This interlobar vein. Now, this interlobar vein, what does it do? this interlobar vein now goes to form what? To form an arcuate vein. Artery rather. Sorry, I'm sorry I'm using vein. I mean artery. So it forms what? It forms an arcuate arteries. You understand? Arcuate artery. Then this one forms a cortical radiated artery. Right? Abi? We call what? A cortical radiated artery. Am I not making mistake? So this cortical radiated artery, remember I told you that it now has something we known as arterioles, right? That I say I'm unable to show in that part. Now look at it. This is an arteriole. Look at this part I'm pointing at. This is an arteriole. Let me reduce the size. So look at it. Let me change the color from black. Change it to yellow. Now look at this yellow. Can you see? Can you see the yellow arrow? So that's the what? That is the efferent arteriole. Can you see it is taking blood into the renal corpuscle? This whitish little thing is called the renal corpuscle. Can you see? It's called the renal corpuscle. And it is inside it that we have the glomerulus as well as the capillaries. Don't worry, we'll talk about that later. Now, look at this is the afferent arteriole. This is the efferent arteriole. Can you see? This one takes the blood inside. This one takes the blood outside. Can you see? So this is the what? This is the afferent arteriole. This is the efferent arteriole. Can you see? Now, this we are not there yet. Let us go back. So I was explaining something. I said this is the afferent. This is the efferent arteriole. So afferent means carrying inside. Efferent means carrying away. So this one is start carrying blood inside. This one is carrying blood away from this thing. Remember I now told you that this afferent arteriole now join into the what we know as peritubular capillaries. So these are the what? Peritubular capillaries. Can you see? The peritubular capillaries. See? So these are the peritubular capillaries. Now all of them now drains into what we know as cortical radiated vein. You understand? So this is cortical radiated vein. The cortical radiated, this is one. This is another. Look at it. This is another one. Look at it. This is another one. Can you see? This cortical radiated vein now goes into the what? Into the interlobar vein. So this is the interlobar vein. Is it no, not the interlobar vein? It is the arcuate vein rather. The arcuate vein rather. So it's supposed to be arcuate vein. It goes into the what? Into the arcuate vein. Now we have one that comes down. Look at it. Here, see. See this one. That comes down here. So let me clean this. The one that comes down here. Look at it. That comes down here. Can you see? So if you notice very well, it later joins this and drains into the what? Into the interlobar vein. Can you see? So that is that and that. So look at it. So it goes into the what? Into the arcuate vein. Everything drains into the what? Into the interlobar vein. Can you see? From the arcuate vein to the what? To the interlobar vein. Then from the interlobar vein to the renal vein. You understand? So that is that and that. So what have I described now? I've described the interlobar arteries, right? Interlobar artery, the arcuate artery, right? The arcuate artery, and I said we have the cortical radiated arteries. Then from there we have the arterioles, that is the efferent arterioles, the peritubular capillaries, the cortical radiated vein, the arcuate vein, the interlobar vein. You understand? And I said we have this. Look at it. This one that they labeled number one. This number one. This G. Can you see? And this one, this whitish little stuff. It is called the renal corpuscle. You understand? That is the renal corpuscle. Now, this renal corpuscle, these white little things, that is where we have the glomerulus. You understand? So this is the glomerulus. And the glomerulus consists of blood capillary, like tufts of blood capillaries. You understand? So it consists of what? This is the glomerulus. Now, so if we open into the renal corpuscle, this is the renal corpuscle. You understand? If we open into the renal corpuscle, we are going to have something like this. Can you see? This is a glomerulus. Inside it, this is a glomerulus. And if you notice very well, there is a white little thing that is covering it outside, like that, covering it from outside like this. That is the Bowman's capsule. It is called the what? The Bowman's capsule. Are you getting me now? So inside the Bowman's capsule, you notice very well that the what? This is the afferent arterioles. So the afferent arterioles brings the blood inside the glomerulus. And the glomerulus consists of blood capillaries. You understand? Blood capillaries that consist of, well, it has some forces. We call it hydrostatic forces. the hydrostatic pressure, rather osmotic pressure, hydrostatic pressure, and the oncotic pressure. We're talking about that when we get to histology. You understand? When we get to histology, we're talking about that. Now look at it. This is the glomerulus. The glomerulus consists of blood capillaries. You understand? Like blood capillaries. Then I will show you a broad view of glomerulus as well. You understand? So that you understand what I'm trying to say. Now inside this glomerulus, can you see we now have efferent arteriole. So efferent arteriole takes it in. Efferent arteriole takes it out. You understand? Efferent arteriole takes it out. So this is the Bowman's capsule. This is the glomerulus that's inside this red little stuff. You understand? Now, between the glomerulus and the proximal convoluted tubule, we have the Bowman space. So this place, look at the place I'm pointing out now. This arrow here, that is the Bowman space. You understand? Then it leads to what? It leads to the proximal convoluted tubule. So the blood that consists of salts, protein, glucose, red blood cell, white blood cell, albumin, nitrates, and anything we enters into the glomerulus through the what? Through the blood capillary, you understand? Through the efferent arteriole, you understand? Then it will be filtered at this glomerulus, you understand? It will be filtered at this glomerulus. But due to hydrostatic pressure, you understand, there will be a very hydrostatic pressure, oncotic pressure, and osmotic pressure around this place. It will push it down. There will be one at this place as well. So it is pulling it. So one is pushing it down. The other one is pulling towards itself. So this is proximal convoluted tubule. Convoluted tubule. Proximal convoluted tubule. Look at it. This coil little thing. See. This proximal convoluted tubule. So there is an hydrostatic pressure as well as osmotic pressure around this place as well. That is pulling the stuff towards itself. But the hydrostatic pressure as well as osmotic pressure around this place is higher than this place when the blood is entering. You understand? Because the blood capillary is going to dilate. You understand? You know, when the this thing receives the signal that the blood is coming, you know what is going to happen? It is going to dilate. The efferent arteriole is going to dilate so that the blood will enter. This will increase the pressure of the what? Pressure of the blood. Now look at it. We now have the what? We now have the proximal convoluted tubule. So this is the proximal convoluted tubule. And in this place, what happens here is the reabsorption of nutrients. You understand? Because if you notice very well, see, can you see that blood capillaries are surrounding it? You understand? So this is the what? The reabsorption of the what? Of some like protein, nitrates, and stuff. You understand? So we now have down. Look at it. It now comes down. It now comes down to form the descending loop of Henle. Look at it. This is the descending loop of Henle, and we have two. We have the thick descending loop of Henle and the thin descending loop of Henle. This is a thick descending loop of Henle and the thin descending loop of Henle. Then we have the loop of Henle itself. Look at it. We have it around there. This U shape of Henle. You understand? Then we have the ascending loop of Henle. So this is the ascending loop of Henle. So this is thick descending loop of Henle, thin descending loop of Henle, and what? The ascending loop of Henle. Can you see it? Now, we now move further upward. What happened in this loop of Henle is also the absorption. You understand? The absorption also occur. Absorption of nutrients, absorption of salts, and other stuff like that. Now, look at it. We now have around this place, this is the distal convoluted tubule. The distal convoluted tubule. And this distal convoluted tubule, it empties. What happened here is that in the addition of hydrogen ion so as to make the urine to be acidic. So now we can now be calling it urine now. But when it is still at the proximal convoluted tubule, the loop of Henle, we call it filtrate. You understand? Because it is not pure urine yet. It is still having some nutrients. So we can now call it urine when it gets to distal convoluted tubule. Then it is passed into the collecting duct. Look at it. This is a collecting duct. You understand? Then this collecting duct, we now move it down. Can you see? Down into the renal papillae. So down here is the renal papillae. Remember I told you, I showed you that the other time, the renal papillae. I'm sorry, my mouse could not reach there. So this down here is the what? Is the renal papillae. Now, if you notice very well, let me just zoom that out. You see that we have two types of nephron here. We have one that the loop of Henle or the tubule is short, and we have one that is long. You see this one that is short is called the cortical nephron. And this one that is long is called the what? Is called the juxtamedullary nephron. Now, look at it. This whole structure that is here, I forgot to mention. This whole structure that is here is known as nephron. You understand? This whole structure that consists of glomerulus, Bowman's capsule, proximal convoluted tubule, distal convoluted tubule, the loop of Henle, it is called the what? It is called the nephron. And what is the nephron? Nephron is the basic functional and the structural unit of the kidney. So let me spell it. Nephron. And it is because of a protein known as nephrin. It consists, the blood vessel, the glomerulus consists of capillaries, and the capillaries consist of a protein known as nephrin. We'll talk about that when we get to what we know as podocytes. You understand? It consists of nephrin, and this nephrin is the word that makes them to give it nephron. You understand? So we have two types. We have the long one, we have the short one. This one is called the cortical, and this one is called the juxtamedullary. Now, one thing you have to notice is that look at this upper part. This upper part is called the what? It's called the cortex, and this lower part is called the what? The medulla. You understand? The medulla. So the glomerulus, as well as the proximal and the distal convoluted tubule. Look at it. The glomerulus, or let me say the Bowman's capsule, the glomerulus, the proximal, and the distal convoluted tubule, they are all found in the cortex. They are all found what? In the cortex. And the loop of Henle, it is found in the medulla. Or let me say the tubule is found in the what? In the medulla. You understand? So that's the reason why we call this one juxtamedullary. Because the the loop of Henle, extend deep down into the what? Deep down into the medulla. You understand? Now, the amount of the urine that they are going to filter, the amount depends on the what? It depends on the length of the loop of Henle. Look at it. We have the thin descending, we have the thin ascending loop of Henle. Can you see it? The thin descending loop of Henle, the thin ascending loop of Henle, the thick descending, the thick ascending. And we have the proximal here, we have the distal here, as well as the what? As well as the collecting duct. So what have I said so far? I said this one is known as the renal corpuscle, right? The renal corpuscle. We have the renal corpuscle here. We have the efferent artery entering the renal corpuscle, and if you open the renal corpuscle, you are going to see the glomerulus, right? Now, inside the glomerulus, it is held by a structure known as Bowman's capsule. After the Bowman's capsule, we have the Bowman's space between the glomerulus and the proximal convoluted tubule. The proximal convoluted tubule, we have it here, move down into the descending loop of Henle, then the ascending loop of Henle, then the distal convoluted tubule, then everything into the what? Into the collecting duct, and this one moving to the what? Into the renal papillae, right? Now, I will show you what happens next, you understand, in the next video. So, this one as well, I said we have type of nephron. We have the what? We have the juxtamedullary, and we have the cortical nephron, you understand. So, these are the two types of nephron that we have. So, this is a structure of a single renal pyramid, you understand, a single renal pyramid. That's the structure, and that is what is inside it. And this is the cortex, this is the what? This is the medulla, you understand. This medulla, it's the salts is like the salt concentration in this part is very, very high, you understand, because from here is where the absorption of salts is going to occur. The absorption of salt. One thing you have to understand is that about 180 liters of blood is filtered per day, you understand, is filtered per day, and only 1.5 liters of them turns to urine, which means 99% of blood that is filtered is going to be absorbed. 99% out of 100%, only one of them will escape, will become urine. 99% of them will be absorbed by the what? By the body. Now, thank you for listening, and the next video we'll be talking about the glomerulus and the anatomy of the glomerulus itself.